All right, please follow along as we review this hard concept of variables. And remember, there's an independent and dependent variable. So I'm going to read the passage to you. If you could follow along, then when I'm done, since you'll have it on video, I would like you to read it aloud as you have the passage on your screen. This is a hard concept, boys and girls. I know every year when I teach this in science, kids struggle with these two variables, so please follow along. Scientists design experiments to search for cause and effect relationships. In other words, they design an experiment so that changes to one item cause something else to vary in a predictable way. These changing quantities are called variables. A variable is any factor, trait, or condition that can exist in differing amounts or types. An experiment usually has three kinds of variables: independent, dependent, and controlled. The independent variable is the one that is changed or controlled by the scientists. To ensure a fair test, a good experiment has only one independent variable. As the scientist changes the independent variable, he or she observes what happens or results from the change. Scientists collect data on the dependent variable to see how it responds to the change made to the independent variable. The new value of the independent variable is caused by and depends on the value of the independent variable. For example, if you will open a faucet part way, which is the independent variable, the quantity or amount of water flowing is what you're measuring, boys and girls. So that's the dependent variable. That will change in response to what you put in your experiment, the independent variable. So you observe that the water flow increases. Experiments also have constants or controlled variables. Control variables are things that a scientist wants to remain the same throughout their experiment. Consequently, they must watch over the constants carefully so they don't influence the dependent variable in a misleading way. For example, if we want to measure how much water flow increases when we open a faucet, it's important to make sure that the water pressure in the pipes, which is the controlled variable, is the same through the entire experiment. That's because both the water pressure and the opening of a faucet have an impact on how much water will flow. If we change both of them at the same time, we can't be sure how much of the water flow is because of the faucet opening or how much is because of the water pressure. In other words, it would be a fair test. Most experiments have more than one controlled variable. So if we look at this example, number one, think about what's the independent variable, what is changed during the experiment, and the dependent variable, what is measured at the end due to the independent variable changing. So you design an experiment wondering, does heating a cup of water allow it to dissolve more sugar? Temperature of the water is measured in degrees centigrade. The amount of sugar is what the scientist is measuring. What are they putting in the experiment to change, and what are they measuring? Independent variable. Think about that. What are they changing? Hopefully you thought it is the temperature of the water, which is degrees centigrade. So they're only changing the temperature of the water to figure out, did sugar dissolve? Did it not dissolve? A little bit. So what are they measuring? And what's going to change because you change the temperature? And that would be the dependent variable. And what are they measuring, boys and girls? Think about it. And that's our dependent. And it is the amount of sugar, which is in grams, which we'll talk about units of science tools later. Hopefully we're getting a little bit better at dependent and independent variables. If you would like, remember, since you have it on video, please read the passage again aloud. It'll help you comprehend it at a deeper level. And let me know if you have any questions.